Welcome once again. Today I would like to explain about the projections of lights. A line means its length, that is, the position of its ends with HP and VP. A line may be parallel or perpendicular to HP or VP. It may be inclined to HP or VP or both. Our aim is to draw its projections, that is, to draw the front view and the top view of a line. Five simple cases of a line are a line parallel to both HP and VP, line perpendicular to HP and parallel to VP, that is a vertical line, and of course a line perpendicular to VP and parallel to HP, that is a horizontal line, a line inclined to HP and parallel to VP, a line inclined to VP and parallel to HP, and finally the line inclined to both reference planes HP and VP, or line inclined to horizontal plane and vertical plane. That is the last case. Now let us consider a line parallel to HP and parallel to VP. The mutually perpendicular reference planes HP and VP are given. Assume that it is the first quadrant, or it is shown as the first quadrant. A line AB, it is parallel to VP, at the same time it is parallel to HP as well. We have to draw the projections of AB, or projection of point A and point B. Both the points are in space, or the line is in space. It is at a distance in front of VP and it is at a distance in above HP. During problems, the distance between these will be given and we have to mark it. So when viewing in the front view, or front view is viewed from this direction always, we get the projections on the vertical plane. The projection of A will be point A and projection of B will be point B dash. We have studied that in front view the projections are notated with a dash, or AB will be notated as A dash B dash. Similarly, in the top view it is projected from top and we get the line AB, small letter AB is marked as the projections. Top view it is marked as AB, in the front view it is marked as A dash B dash. This is the projection method. And for convenience of drawing, this horizontal plane is rotated to this direction and vertical plane and horizontal plane will be in the same plane and we can draw it easily. That is A dash B dash. This is the distance above HP and AB, it is in front of VP. If this distance is given, we can mark it here and draw the line. Both the views, front view and top view, gives the true length of the line. Or if the line is 50 millimeter, we can mark 50 millimeter here. Here also it will be 50 millimeter. That is the method. It's orthographic projection. Both front view and top view are parallel to XY line and both show the true length. A line perpendicular to HP and parallel to VP. Next case. This is a vertical plane and horizontal plane. A line is perpendicular to HP and parallel to VP, or a vertical line. Line AB. its front view will be point A here and B here, or A dash is marked here and B dash is marked here. It is a method of projection, A dash and B dash. And in top view, both A and B will be seen as a point. In top view, A and B will be at the same point and it is marked as a point A, B. Well, these are the projections. When drawn in the same plane, we can mark it as A dash, B dash will be like this and AB will be like this. So this point or the line is at a distance 10 millimeter above HP. We can mark 10 millimeter here. And if the line is at a distance 30 millimeter in front of VP, we can mark AB at a distance of 30 millimeter away from XY line. Here also, the front view gives the true length of the line. Front view is a vertical line showing true length and top view is a point. Case 3. A line inclined to HP and parallel to VP. This is the line AB, which is inclined at an angle theta to HP. At the same time, it is parallel to VP. Parallel to VP and inclined to HP. So in the front view, we get the true length of the line. So A dash, B dash will be marked like this, the front view. And in top view, the distance or the line will be seen as a short line. In top view, we mark AB like this. So the true length will be seen in the front view only. In top view, we get a reduced dimension as AB. These are the projections. So these lines are called projections. We are drawing these lines. Say line AB inclined at an angle 30 degree to HP. The point A is 30 millimeter above or 10 millimeter above HP and 30 millimeter in front of VP. We have to mark point A dash here, 10 millimeter above XY line and 30 millimeter below XY line, point A. We mark the true length, or given its length is 100 millimeter, we can mark A dash, B dash as 100 millimeter and its top view. It is projected downwards. We get the top view AB like this. This is the method of drawing orthographic projections. Front view is inclined to XY line and top view is parallel to XY line. So here the front view only gives the true length of the line. Third case, a line inclined to VP and parallel to HP. This line AB is inclined at an angle, say 45 degree with VP. Inclined 45 degree with VP, but parallel to HP. First of all, we are drawing its top view. So point A, B, top view. Point A, B will be here and its front view is marked here in this direction. Front view is A dash, B dash. This is the method of drawing front view. And in orthographic projection, the front view is marked at a distance above the XY line and top view will be marked in front of XY line. Here the length of line 100 millimeter is marked in the top view and in the front view it will be in reduced position. This is the angle of inclination with the vertical plane. Please note The angle of inclination with HP will be theta always. The angle of inclination with vertical plane will be marked as phi always. Theta and phi. Theta is the inclination with HP and phi is the inclination with VP. A line inclined to both HP and VP. This line AB is drawn as inclined to both VP and HP. So here it will be the front view and this is the top view. This is the inclination of the front view. This is the inclination of the front view or A dash B dash with XY line. This line is drawn parallel to XY line and the inclination of the line with XY line is marked as alpha or it is known as alpha. And inclination of the top view or AB with XY line, this is parallel to XY line. This is XY line, this is parallel to XY line and inclination of the top view with XY line is marked as beta. Please remember this parameters alpha and beta. Alpha is the inclination of its front view with XY line and beta is the inclination of its top view with XY line. It's the projections. These are the projections. So here in this cases, both the lines are not the true shapes. A dash, B dash and AB are not the true length. Front view is an image on VP, that is A dash, B dash, and top view is an image on HP, that is AB. We have removed the line AB. These are the projections. Or it is drawn like this. And if you want to find the true length of the line, another method is used. Orthographic portion. Front view is seen on the vertical plane clearly. To see top view, HP is rotated. It is rotated 90 degrees downwards. Hence it comes below XY line. Projections. These are the projections. Please note that the final view of the line is marked as thick lines. Here these two are thick lines. All other lines are thin lines. I have already said in previous videos that thick lines are thin lines. Thick lines are drawn using 0.7 millimeter thickness pencils and thin lines are drawn using 0.3 millimeter pencils. Here both front view and top view are inclined to XY line. No view is parallel to XY line and both front view and top view are reduced lengths, not true lengths. No view show true length. Please note that. Another method is there to find the true length in this case. So here the same old figure is given. Front view and top view of lines are given. For alpha and beta are given. A dash, B dash, AB are given. Or front view and top view of a line are given. Alpha is the inclination of its front view with XY line and beta is the inclination of its top view with XY line. It is given. We have to find the true length of the line and true inclination with say HP or VP. or both. Top view AB, front view A dash B dash are not parallel to XY line, hence its front view and top view are not showing true length and true inclination with HP and VP. When front view and top view are known, the procedure to find the true length. Here the views are rotated. Here the top view is rotated, or with the center as A and radius equal to AB, draw an arc to meet the locus of A. This is the locus of A. This is the locus of A dash. To meet the locus of A. From there, it is projected upwards. So locus of A, it is denoted as B1, and at the locus of B dash, it means at the point B1 dash, and join A dash B1 dash. This is the true length. A dash B1 dash is the true length and gives the true inclination with HP. So here, this is the line. A dash B1 dash is the true length of the line inclined at an angle theta with HP. Similarly, we can find the true inclination of the line with the VP also. For that, with the center as A dash and radius equal to A dash B dash, you draw an arc which will cut here. That point is denoted as B2 dash here. It is dropped down. Here we get B2. From there, taking radius A, B2, draw an arc to cut the locus of B. I repeat. With A dash, B dash, you draw an arc. To cut the locus of A dash. From there, drop a line to meet the locus of B, so that A, B2 will give the true length of the line and inclination of the line with VP. Here top view AB is rotated. I repeat, top view AB is rotated to get AB1 and made parallel to XY line. Hence its corresponding front view A dash B1 dash. It is front view of A B1. A dash B1 dash is showing the true length and theta giving the true inclination with HP. This is how the views are drawn in orthographic projections. First of all, locate A dash A. So here the true length and inclination with the HP and inclination with the VP are given. Inclination with HP is theta. Inclination with VP is phi. This is given and the length of line is given. So you can mark A dash B1 dash taking theta and A B2 taking phi. Now draw the locus of both B1 dash and B2. We have to get the positions A dash B dash and AB. For that, the method is project B2 from here to here, that is to locus of A dash. From there, with A dash as center and AB2 dash as radius, draw an arc to cut the locus of B1 dash. Join these points A dash, B dash, which is the required front view of the line. Similarly, project B1 dash downwards. This is the point B1. With the center A and radius equal to AB1, draw an arc to cut the locus of B2, which is the point B. Join AB, which is the required top view, for A dash, B dash and AB. It's the top view. This A dash and A will be on a straight line, and B dash and B also will be on a straight line. This is the method of drawing the projections of lines. If the true inclinations or the final views are known, we can find out the inclination of the lines and true length. Similarly, if true length and inclination are given, theta, phi and true length are given, we can draw A dash, B dash and AB. This is the method of drawing orthographic projection of lines. The same figure is shown here. A dash, B dash, A dash, B1 dash, B1, AB, A, B2, B2 dash, A dash, B dash. This is in the straight line. This is on a straight line. Theta, phi, alpha and beta. So these are the important 10 parameters to be remembered with the notations. True length TL, A dash, B1 dash and AB. A dash, B1 dash and AB are the true length. Angle of true length with HP, theta. Angle of true length with VP, phi. Angle of front view with XY, alpha. And angle of top view with XY, beta. Also, position of A, or the distance of A and A dash from XY line. Position of A is given. In a problem, the position of A is given. That is, the distance from XY to A dash and A will be given. These are the positions of B or B dash and B dash and B are given. Front view is always noted as A dash, B dash, and top view AB are usually drawn in thick lines. All other lines, including XY lines, are thin lines. Or the thick line are drawn. The thick line is drawn using 0.7 millimeter thickness pencil, and thin lines are usually drawn using 0.35, that is not available in market. So 0.3 pencil is used to draw thin lines. Theta and alpha are constructed with A dash. Please note this. Theta and alpha are constructed on A dash only. Similarly, phi and beta are constructed with point A only. Also, B dash and B1 dash are on the same locus, and B and B2 are also on same locus. You have to study this or by heart this. The true length is never rotated. Its horizontal component is drawn and it is further rotated to locate view. Views are always rotated, made horizontal and further extended to locate true length, theta and phi. We will understand the projection of lines as we go through some problems only. Thank you for watching. Thank you.